Okay, so we've been using functions. We've been using functions almost from kind of day one in this course. We've been using kind of built-in functions that have been written and provided for us. And in one of the surveys, someone asked a great question: what's the difference between a function and a method? There's a lot of similarities between the two. Both of them are things that you call to perform computations and operations, and both of them can take arguments, as we'll see. The primary difference is that functions are standalone, and we're going to talk about today how to write functions. And so they're standalone; they're not attached to any object. And so when we use a function, any data that function is going to operate on is going to be passed in to the function inside the parentheses as an argument. Methods, on the other hand, methods are called on existing objects. And so if you have a table using the dot notation, we have a table called like MBA, MBA dot show, right? That is a method. That is a method performing an action on the table object, okay? But they both are used to do computations and do useful work. And today we're going to learn how to write our own functions. And so before we kind of look at how to, let's look at the anatomy of a function, okay? Functions, Python gives us the ability to create our own functions, and our own function definitions start with the keyword DEF. And so that is short for a function definition. So this is how we define a particular function. And the way you want to think of a function is it's a way of giving a name to a group of code, a block of code, or a set of computations that you're going to want to do probably multiple times. Functions are good in the world of computer science because they allow for code reuse. So instead of writing out all the steps that you would have to do to perform some function, you just define this function once, and then you can call it. You can pass in data. And so all functions have a name, and that follows the function definition. And functions may or may not take arguments, okay? Argument names are go inside of the parentheses. And if your function doesn't take any input, doesn't take any arguments, you'll still have the parentheses. There just won't be anything inside of the parentheses. But you can have 0, 1, or more arguments. And if you have multiple arguments, the argument names are going to be separated by commas, okay? And all the arguments are going to go inside of the parentheses. And then this colon lets you know that this is going to be the start of the function. And then lines underneath this function, and in Python is in particular, they need to have this, all of the lines in the function have to be indented to the same width, okay? In this case, there's just one line in our function, and so you can see how it's indented. But if we had multiple lines of this function, they're all gonna need to be indented to the same width. Okay, and then if you want to get a value back out of the function, you pass that with the return statement here. Those are the bodies. And in this case, right, this function is going to create the spread. It's going to give us, if we pass in, so values, if we pass in an array, it's going to give us the difference between the maximum value and the minimum value from there. And this is the return expression. And so when we call a function, most of the time we expect that function to return some value, right? That's the value of that expression, which will either save as another object. And what gets the value of the function call is going to be defined by this return expression, and that is denoted by the keyword return from there. And so all functions follow this this format. They have the name, they have the definition followed by the name, any arguments, the body, and then most functions end with a return statement from there, okay? And so let's actually take a look at some functions. Okay. Go up to the top. So here's our boilerplate, and here's now our first function definition, and it follows the nomenclature that we had in the slides. So it starts off with the keyword def, and then the name of the function. We can give it any name that we want, following the same rules that we named our object in the system, insofar that you can't have any spaces, and it has to start with a letter. You can use numbers, but no punctuation other than an underscore. So your function name has to start with a letter, can't start with a number, but it can have numbers in it. The only punctuation you can use is the underscore. So here we're defining a function with the name triple, and it has one argument, which we will call the name, we'll give the name x. This x, we can give it whatever name we want, but much like choosing the names for our objects in our systems, the more descriptive the name is, the easier it is to understand what your function is doing. So for this example here, it's such a short function, you know, x is a perfectly fine name, but as we write more complicated functions, it's often worth taking a moment or two to think about what is a good name for our argument, because we're going to use this name inside of the function. And so in this case, what we're doing is the body is just this one line of code where we're returning 3 times our input, is really how you want to think about what that function is doing. It is taking whatever is going to get passed in when we call that function, and it's going to return 3 times that value. So first we need to define this function. So if I skipped over, like if I forgot to do that and I actually called this, I'm going to get an error because Python has no idea what the triple function is yet, right? So that's giving me a name error, and it's saying triple is not defined. That's because we haven't done a function definition yet. So now when I run this cell, and nothing's going to happen, I mean, nothing is going to show up to the screen, but now it will define that function. And so now when I call triple, it's going to pass in that value 3. It's going to pass in that value 3, and that value 3 is going to be contained in the object x. So when we call with the input of 3, x is going to have the value of 3, and it's going to perform the body of that, which is going to return 3 times x, and in this case, 3 times 3. So the value of this call, so what we're going to say is when we execute this line, we're calling the triple function with the value 3. And that whole thing is going to evaluate to whatever the return value is. And so when we call that, this whole thing is going to evaluate to 9. Okay. And if we wanted to keep that, we would assign it to some object. And so if we want to say value, val equals triple, and then we can use the value. We can use the value from that function later in our program. Okay. And so it doesn't have to be a number that you pass in. It can be any other object that has been previously defined. So if we save the value 4 to the name num, we can call triple with the name num. And so what should that return for us? It should take our input, whatever the value of our input is, and return us 3 times that value. So that should, the evaluation of this function, we call this function, it should have the value of 12. Okay. And it doesn't even have to be, it could be any expression. It can be any expression that could get passed in. And so in this case, what we're doing is we're passing in num times 5. And so how that works is before the function is going to get called, before the triple is going to get called, it's going to evaluate this expression. It's going to actually do the math for us, and it's going to come up with a value for that expression before it calls the triple function. So in this case, we're going to take num, which has the value 4. We're going to multiply it by 5, And so we're going to pass in the value 20 to the triple function. And when that gets tripled, the value of this should be 60. Okay? Any questions about that? So basically, the way I like to think of functions is that you pass in a function, with a function, you pass in some value. And those are defined by your arguments. Some computation is going to get done, and then it's going to give you back a value, which is the value of that function call expression from there. Okay, so here's an interesting thing. What happens if I just evaluate x, right? So here's this function call, right? We're here inside of this function, we've defined this name x that will, whenever this function gets called, it will have the value of whatever was passed into the call, whoever called it. Now, is x actually defined in our program? So if we can just see by trying to evaluate it, and we see it gives us a name error, and that's a good thing. That's a good thing, because this x in computer science speak, this x has the scope of the function. That's just a fancy way of saying this name x is only defined when executing the code inside of this function. It doesn't live outside of this function. And so, for example, if I say x equals 5, okay? If I say x equals 5, and now I call triple 2 times x, that should return us, well, x is 5, so we're multiplying it by 2, that's 10, we're gonna triple it, that should return us 30. What is the value of x? What is the value of x? And if you can see the comment, it should still be 5, and it is, because this x is defined outside of a function, it has global scope, we can use it in any of our cells. This x here, this x is defined only when executing that function. And it's going to have the value of what we pass in. And then when that function is done executing, this x no longer exists. It is tucked away inside of the function. And this is a good thing. This is, in computer science land, this is the concept of encapsulation. And what that means is we don't need to know what variables are being used or defined inside of a function. All we need to do is we need to just understand the behavior of what a particular function does. And there's not going to be any conflict of variables from there. So we don't have to worry about the variable names in any of our functions. Those are limited. The lifetime of those variables, of those names, live only when it's executing a function. Okay? And in Python, we can pass in numbers, strings, anything into a particular function, and the function won't give an error as long as the type that we pass in is compatible with the instructions in the body of that function. Okay, so if you remember, one of the things that you can do to strings is you can actually multiply strings by a number, which is kind of a funny thing to think about. And if you remember what it does, it actually just concatenates the string however many times you multiply it by. So I can call triple on the string ha, and it's going to return ha ha ha. A little joy and mirth for a Thursday, okay? That's because that operation made sense. You can actually multiply a string by 3. And so that will also work with arrays. And so if we use the array range function, this is going to create an array for us from 0, 1, 2, and 3. And it's going to pass that array into the triple function. So it should return us an array with all of those values tripled. And in fact, it does. It returns the array of 0, 3, 6, and 9 from there. Okay? Any questions about arrays? About functions and function definitions? We'll get some practice defining them. Any questions? Okay, fantastic. All right, so, okay, so let's kind of take our newfound knowledge of functions, and let's think about, can we figure out what function this will do? So when we think about functions, I always think about them in a couple of terms. I think about functions in terms of what are their inputs? What inputs does that function take? What are the valid types of inputs that that function supports? And what does that function return? What is its output? Okay. And so if we had this function, which I've given intentionally a very nondescript name, let's see if we can kind of decode, what does this function do? What input does it take, and what output will it give? And kind of when we figure that out, what's a reasonable name for that function? So to take a moment and just kind of work through what's going on here. And so if you notice, functions can call other functions. So to get a sense of what it's doing, think about what are we doing with the input, right? So our input is S. So how is S being used? What functions is S being passed into, and what are we returning?
Is it taking the percentage of something and then rounding it to 2 decimal places?
Ah, yes. So yeah, so the big clue here is kind of this round, right? And so if we think about what's going on here, so we're taking S, and notice here this sum of S, okay? And so what type, and so it's always good and useful to think about what types particular functions support. And so the sum, when we call sum, what gets passed in? What type get passed in? I think I heard someone say the right answer.
An array.
That's right. So this sum function supports arrays. And so, to answer the question, what kind of input does it take? Well, then S, we should be passing in an array to this function. And that's exactly right. So it's going to give us, it's going to compute the sum of this, and then we can support division on individual elements of the array. And so it's going to take the sum, which is some number, and it's going to divide every element of that array by the sum. And so that's giving us the fraction, right? The percentage of all the individual elements in our array. But to make it into as a percent, we're multiplying it by 100. So that's what this inner thing does. And notice that whole expression is what gets passed into the round function. And then the round function takes a second argument, which is how many decimal places are we going to round to? And then it's going to return that value. So let's actually take a look at that. And so what does that look like? So here's the function, now more aptly named, percent or percent of total, I think are good names for that. And then when we define that function, again, defining a function, it doesn't call the function, it just it allows you to call the function. And so now we can pass in any array. So here I'm passing in the array 1, 2, 3, and 4. And so when we do that, we get back an array where each one of these is the percent rounded to the appropriate decimal. But for this number, it was a whole, all these things work out, right? Because this gives us 10. If we take the sum, 1 plus 2 plus 3 plus 4, that gives us 10. So 1 is going to be 1 over 10, so 10%, 20, 30, and 40. But if we call it again with a different array, if we give a different array as input, we're going to get a different array as outputs. And then here we actually get the we get to see the rounding in use. from there. Okay. Okay, so when we write functions, it's very helpful because we write functions because we want other pieces of our code or other people to use our functions, to call our functions. And Python is really cool because it actually is a self-documenting language. You can write the documentation for your functions inside the function themselves. And anyone who wants to use your function can get the documentation for that function. And so how do we do that? We do that in something called Python docstrings. And these docstrings are just basically a description of how you expect that function to work. You give it, so some of these docstrings can be very detailed, that lists examples, that detail all of the inputs, all of the outputs. But we can do that from we can do that by ourselves. And so here is a docstring for the function that we just wrote. And so docstrings, they start in triple quotes. So notice the triple quotes here, and those will, and I'll show you how to read docstrings from there. But I think it's easier to see in demo form. So let me hop back to our demo here. And so here's our function with our docstring, okay? And so here what I've done is, so I've kind of cleaned up our function. So I gave it just this percent of total as a good name, but percents is a little more concise. I've changed the input from being S to counts. And then I've given it a docstring. So convert the values in an array, right? So in the array, so I'm kind of letting you know that a valid input for this function is going to be an array. And I'm telling you what I'm going to return. And so I'm going to return an array, right? So I convert the values of an array to an array. So I'm letting you know that I'm going to return an array. So you know that you should be passing in an array. You're going to get back an array. And I'm explaining what the function does, right? It's an array of percentages out of the sum of the array. And here, and again, all included in the triple quotes, I've given an example of how to use it. And so these three little greater than signs, those are the interactive Python prompt. And this is just the format that docstrings use for showing examples. And so this is showing you an example function call. If I did the percentage of make array 10, 15, and 25, this is what I would get back. I would get back 20, 30, and 50 from there. And then we end with that, right? So this is basically one big string, one big docstring, and then that's not part of what actually gets executed when you call. This is really a comment, a documentation comment explaining how the function works. And so then the other thing I did to kind of clean up this function is instead of having it just big one long expression here, I broke it up. I made the sum into the total. And I think, from a readability standpoint, this is a little easier to understand than up here, right? Because here you kind of have to work through exactly what's going on to figure out what it's doing. But in this case, right, where you can see that I'm clearly taking the total as the sum, and then taking the individual counts, each of the individual elements of the array divided by the total times 100. It's a lot easier to see exactly what's going on. Okay, so now if I define that function here, one of the things that you can do, and this is a Jupyter Notebook thing. So if you want to see the documentation for any function, that has a docstring associated with it, you can just type the function name with a question mark. And so it is your way of asking for help. And so if we evaluate this is going to return the docstring. And you can see it actually shows up in a separate window down here. It shows up in a separate file, and it's showing us, can everyone see that? it's showing up, it's showing the signature. So this is just the inputs and outputs, and it's showing it's taking a count, and it's showing us the doc string. Here's the doc string, and then it's showing us an example of how to use that. Okay. And so here, if I add another cell, you can do that with pretty much most any function. So for example, if you wanted to see, so so I used the sum method, right? But that's on a table. But if I wanted to see the built-in, I should be able to do sum ? And then here's the doc string for that, right? We can make this a little bigger. And it's showing you return the sum of the start value plus iterable number. So, some of the doc strings kind of talk in Python speak. But I think I could do table, no, if I can type table.sum ? No. That's what happens when you try to do live demos. But if there's a function that you're not sure how to use, you can try always putting the question mark after it. And then another way of doing that is that there's a help built-in function. And you can just call it, you could just pass in a function name. And that will show you, instead of showing up in a separate window, it will just show you kind of inline from there. Right, so you could do something silly like you can do help, and that will show you the help function there from there. So that's pretty useful if you're not exactly sure what something is doing in Python. Okay, any questions about that? Okay, let me go back to the demo and kind of wrap up the demo, and that might just be as far as we get today. So you can pass in multiple arguments to a function, and when you define them, when you pass them in to a function, you separate them by columns, and when you define a function, you do exactly the same thing, you separate them by commas. And so this function here, this will calculate the hypotenuse by calculating x squared plus y squared. And from there, and then if we call that, that returns that, and then 2 plus 2 should return us, 2 squared plus 2 squared is 4, it is the square root of that. Okay, so if you have multiple arguments, you just separate them by commas, both when you call a function and when you define a function. One of the things that you can do, and a lot of the data science methods and functions in the data science package make use of this, so it's worth kind of pointing out, is that you can have default arguments. You can have arguments that are optional, okay? And so if we took this hypotenuse function that takes 2, we can add a third argument, okay, decimal places. And that's going to tell us how much we want to round by, okay? And so if we do that, and here we're just going to make use of, so this hypotenuse round is going to make use of our previously, so we're going to compute the hypotenuse like we just did before, right, with the hypotenuse squared. And then instead of just returning the answer directly, by squaring it, we're going to run it through the round function first. By define that, and then calls that. So that tells us how many decimal places we wanted to round to, right? If we wanted to do that too, that would round to there. If we wanted 5, we can do that. Okay. However, if we called it, right, so now that we've specified this argument, this last one, this decimal places, once you've defined an argument, you have to, in the function definition, it has to be called with all of the arguments you've defined. So if I go back and I call it without the third one, that's going to give us an error. That's going to give us an error. But sometimes most of the time, so for some functions, you may just want to have a default if the user doesn't specify an argument to use some reasonable value. Okay. And so Python allows you to have default arguments. And so here, just like we did before, this decimal places, we define it. But what we do is after the definition, we have this equal to. And what that's saying is that if the user doesn't specify a third argument, assume the default value of 2 for the decimal places argument. So if we define that function and we call it, and if they pass in an argument, if we pass in an argument, the third argument there, overwrite the default value, okay? So if we call this with 3, it's gonna do exactly what we thought it was gonna do. It's gonna round to 3 decimal places, right? And if we call it with 5, it will do that from there. But now if we leave off that third argument, this will work properly. It will not give us an error, and it will go to the default. Okay. And so a couple of restrictions on default arguments. Default arguments, you can't have any non-default arguments after your first default argument. Okay. And so I couldn't do something like this. I couldn't define a non-default argument Z after a default one. So if you have a default argument, all of the other arguments after that must also be must also have a default associated with them. And if you have multiple default arguments, you have to refer to them by name if they're coming out of order. And so here we explicitly name the default argument that we want to set from there, and Python allows you to do that. Okay, but we can't give it any old name that we want. This decimal places has to match. This name has to match the name in our function definition. So if we just did places before, the name, you're going to get an argument mismatch, right? And in particular, you got an unexpected keyword argument, right? You got an unexpected argument name, places. It was expecting something that had the name decimal places from there. Okay, all right. I don't think we have enough time to start another topic. So I will stop us here, and I will entertain any questions you guys might have for like 3 minutes. We'll get some practice. We'll get some practice in lab, writing functions and using them. The key, the sneak preview is what comes next is we're gonna take advantage of the fact that you know, when we have an array and we can like multiply all the elements in the array, we're going to be able to do the exact same thing with columns in our table. So the next thing is going to be this apply method. And what that's going to do is if you apply a method on a column, it's going to allow you to call a function on every element in the column automatically for you. And so this is really where functions are going to get a lot of power, because we now can, once we've written our functions, we can now apply them to arrays. We can apply them to all the elements in our array. So we can apply a function to a column of data. And that's kind of the next step in our journey. And once we do that, we can really start doing some amazing kind of data analysis on our tables. Right now we are at the mercy of the data science library package, and that can get us really far because it's a pretty feature-packed library, but there's going to be times where you want to do things that are going to be very custom. And basically applying a function to a column is a very convenient way of doing that. So that's what we'll pick up with on our next class. All right, so any questions? Any questions with that? Okay, great. Well, I have office hours starting at 3. So if you have any questions on the homework assignment that's due tonight, pop in my office hours. Here, let me stop the recording because no one, this does not need to be.
All right, so welcome to today's lecture. I was saying earlier that we're gonna resume from the apply method. And even though we had seen it's being used in the lab, I think last week, but let's try to cover it more thoroughly so that some of you can resume, keep doing your lab, as well as I think the homework can also be related to the apply method as well. And it is a really widely used method. You will see that throughout this course anyway. So let's start from there. So this is the topic 7, the functions topic. And then the apply method, I think Jason talked about it to some degree. So for me, I wanted to take it from doing the entire demo, maybe, like to make sure that we all on the same page. So the method, so the apply method, as we know now, is that it's going to create an array, okay, by calling a function on every element in a particular input column, okay? And you notice that we're doing like columns. So in fact, you could apply the apply method to multiple columns depending on the function they're doing. So this again relates to, if you remember, some function only takes one input, right? Sometimes a function may be compared to columns at the same time, things like that. So you could do it for multiple columns. But for what we're focusing on right now is just to give the demo and then try to make sure that we all understand how we can do the apply method by calling a function on a input column. So the example I think you have seen is this people with their birth year. Okay, so we only have 4 people here, okay, 4 names and then the 4 birth year. And we can do like what we're talking about, since this the apply method, we know that it's being a particular function that you want to call to an entire column that you want to do. So there could be many things you can be doing, right? So one thing we're saying that, well, we know the birth year, like there are 4 different birth years. And what if we want to cap the birth year at a particular number, like 1980, for example? So the one function that we want to use to do that is, well, in this case, we actually write a function. So the function name is cap underscore at underscore 1980. Okay, and the input could be like in this example, the input, when we looking at it, the input could be a array or just could be a scalar, whichever. Regardless, we're going to take that input and return the minimum between x and 9080. Okay, so that's why if I apply this cap at 9080 to 9075, then we're going to return the minimum, right, between 9085 and the 9080. And then the minimum, well, as we know, is 1985. So we're going to do 1985 here. However, if we're inputting a value that is greater than 9080, then we know that it's going to be capped at 1980. Okay, so that's why if we do 9091, okay, it's going to be 9080 being returned. Okay, so that's what we mean by cap at 1980. Okay, so that's when we applying this function by inputting a particular scalar like an x and then trying to return the outcome. So again, on the apply method that we're covering here is that we can now apply this function, okay, on this entire birth year column. Okay, so the way to do that, okay, again, applies a method on tables. Okay, so the table name is ages, and then we do dot apply. And the inputs here, the first one is the function that we want to apply. That's the name of the function. So it's cap at 1980. The second is in quote, the column name. Okay, so we can do that and let's see what's the output. Okay, so remember the apply going to return you an array. Okay, that's why we're seeing this. And then cap at 1980 for those 4 numbers, we know that, well, the first 2, they're greater than 1980, right? So they're going to be capped at 1980, whereas the last 2, they are smaller than 1980. So they're going to just be reported by their original values. Okay, so that's why you can see that we can define whatever function that we want to be applied to a column. Okay, and what's more, keep in mind that the apply is returning you a array. Okay, so maybe let's just say like you wanted to attach this column, attach this array into the original column and then just call it like capped at 1980. And now we know in order to do that, the apply method gives us an array, right? So in order to do that, if you roughly remember, we're going to do ages, right? And then with column, because I want to add that in, right? I want to add that in, just call it cap at 1980. That's the name of the column. And then I supply the array. And the array will be exactly what we applied that function earlier. So if I do this, I believe I will be adding this extra column. Okay, so depending on the goal, okay, again, you probably see this occurring many times that we're saying that there are many ways that you can achieve a goal. And then also one particular way probably needs to be broken down into multiple steps. Okay, so for us, we are learning more and more methods that we're able to do. And now, like say, we can write our own functions. We can even do apply the function into onto an entire column. And then depending on the goal, let's just say like, if I only really want to know the capped values, and returning the array will be good enough. Or maybe in some cases, you do want to add that array as a new column into the original table, then you can just do what we did before using the with underscore column method and go with all of the syntax that's needed for that. Okay, so again, depending on what you want to do, and we really need to synthesize, I think, as you will see more and more, that as we learn more stuff, we need to figure out what task can be done by what method. Okay, and then in order to do that, it does take the synthesis of all of the experience that we have so far. So it is part of the learning. So don't get stressed out that, oh, I forgot, like, oh, we learned this before. So always go back to check like the demo, the lecture slides, or even on our website, I think you notice that we have a help, like a Python helper page with all of the different methods that we've been learning so far. So that can be like a good Control and F thing if you want to do, just to search what you want to do. Okay, actually, honestly, I do that all the time because I keep forgetting about those arguments. Like say when I'm trying to do .where, and I'm trying to do like, oh, is it exactly like strictly above certain values, strictly like between two values? There's so many different arguments that we can do. So for me, I always do like Control F .where, and then I'm gonna go to that box to figure out which one is the one that I'm needing. Okay, so don't feel bad of doing that. That's part of learning. And then not only learning, I guess, part of doing it as well, moving forward. Okay. All right, so the last part is we're doing a new function called name and age. Okay, so the age is defined by 20 to 21 minus the birth year. Okay, and then the return actually, as you notice, is actually the name plus like a string is, and then the string of age. Okay, so what we're doing here is that we are defining a function called name and age. There are two inputs, the name of the person and then the birth year of that person. Okay, now you're looking at it. This is actually a great example of what we were saying earlier, that the apply method can also be done for functions with multiple inputs. Okay, so here, this name and age, as you can see, we need the name and we also need the year. So as you could imagine, once we define this function, and then if we want to apply it into a table with multiple columns, then we're still going to do the table name, right, apply. And then the first input is always the name of the function, okay? And then in this case, the name of the function is name and age, and it does take two inputs. So we're just putting the column name in quotes accordingly. So we're able to pass the person column as well as the birth year column. In the end, we'll be able to returning I guess each statement about who is at what age. Okay, so let me run that for you. Okay, so don't forget, it's always an array being reported. Okay, so that's why when you run this, it's going to give you an array, but it's going to be an array of strings. Okay, Jim is 36, Pam is 33, Michael is 54, and Creed is 117. Okay, so depending on what you want to do, we're using this small example to demonstrate that the apply method, how to do it. And then you could be function with only one input. It could be function with multiple inputs, and it can be pretty flexible. And for us also, please keep in mind that the output is an array itself. So if you wanted to do anything about it, you might have to do extra stuff like attach it back to the table, for example, using our familiar with underscore column method. Okay, makes sense? Apply now? Okay. Yeah, again, I think last week we got the chance to do some of it in the lab already. So hopefully now seeing this full example, and then maybe that can connect to what you had done before. And then maybe if you haven't finished lab 4, feel free to do that as soon as you can. Okay, so on the slide, we now have introducing the apply method in general, and then also the 2 different methods I was talking about, like if it's 1 argument function or if it's 2 argument function. Okay, so really pretty flexible. I could imagine if we want to do like even more than 2 arguments, I'm pretty sure it should be doable as well. Okay, so it really depends on the goal and then what you want to do about the table and what kind of output that you are looking for. Okay. All right, so I think that ends the discussion about apply. And again, revisit the demo, revisit the lab to make sure that you get a solid understanding and practice of this. Okay, so the last topic of topic 7 functions is prediction. Okay, so this again, if you recall, at the beginning of the semester, we're talking about the goal of doing data science. Okay, we're talking about like, we're trying to visualize data, right? And we start to do that with multiple visualization methods like scatter plot, line graph, as well as bar plot, right? Different bar graph, different style. And depending on what kind of variable you're working with, you're going to choose, and histogram, I forgot, histogram is very important as well. So it depends on what kind of variable you're working with, you're going to choose the appropriate method to visualize it. Okay, so that's usually the first step. And then after that, we want to do certain inference. Okay, we want to make useful statements or solid or valid statements out of it. Okay, so that's inference part, which we'll get to do a lot more later as well. And then usually a very important next step of doing data science is making predictions. Okay, so here we just wanted to give you like an overview, especially like prediction can be done through functions. Okay, so that's why we put the prediction topic in the first place. The first time we're introducing it right now in the functions topic, but later on you're going to see even more methods of doing prediction. Okay, so prediction, nothing fancy. There are so many different ways you can prediction. And of course, some maybe are better than the other. And then when we say better, you could imagine that you want to have higher prediction accuracy, for example, things like that. So naturally, I think there are certain methods to compare different prediction methods. So for now, for today, we really just wanted to show you how one type of prediction can happen, as well as how to do that through function. Okay, it's really trying to empower you to use what we have learned so far to do new stuff that you probably have not thought of yet. Okay, so the example we're going to go with is Sir Francis Galton. Okay, maybe some of you know this name. And he was actually Charles Darwin's half cousin. Okay, he was knighted in 1909. Okay, he was a pioneer in making predictions. Okay, there's some controversy, but overall, he was really like a very important pioneer in making predictions. Even back then, you can imagine like he was born in 1922 and then died in 1911. And then there are not many tools out there, right, to do any kind of data, even collection, but then let alone to do like afterwards. So he was definitely a pioneer. And then maybe in some other mathematics, statistics, or computer science courses, you have heard his name before. There's certain stuff that he did in many computing aspect as well. So maybe you will see him again in other contexts. Okay, so for us, we're gonna start with this prediction method that he proposed back then. Okay, pretty straightforward. And then you will see that, well, it doesn't seem to be something really fancy. But for us, one thing is how to think about prediction. Okay, and then the next is, like I said, how to make it work in Python through making functions. Okay, all right. So to get us started, I wanted to first show you the data set. Okay, it's a really rich data set. So for us, we're going to select a few things about the Galton data set. So what he was doing back then is that he was collecting information about father's height, okay, mother's height, and the child's height. Okay, so what he was curious about, and I think many people are, or like there's certain, I don't know, common sense, like thinking about how you can determine in some sense like the child's height given the information about the parent's height. So one thing we're doing here is focusing, like I said, in inches here, the father's height, mother's height, and child's height, okay? Adult child, okay? So one thing I wanted to show you is that we can do what we call overlaid histograms, okay? So here, it's interesting over here is that while we have the father as a column, right? The mother height as a column, child height as a column. So we can always like visualize them using histogram one by one, okay? But sometimes it's really interesting, especially if we're curious about the mother's height and the father's height effects on the child's height, we might want to put all of them in one graph just to see how things are looking, okay? So that's what we're doing here with overlaid histogram. So let me start with regular histogram. Okay, we can do all of the ones for the father, all of the ones for the child, for example. But then if you want to do for all of them, especially if you look at the data set, we have father, mother, and child, okay? And the data set is called height, okay? So if you want to do overlaid, nothing fancy, you can just do height under dot histogram. So hist is still the method, okay? And we wanted to do bins for, like, say, a particular range over here. So if you do not supply a particular column that you want to do a histogram for, it's going to automatically do the overlay histogram for you for all of the 3 different columns. Okay, so let's see what we get over here. So they're going to do the automatic color coding for you. Okay, and then in particular, they have fathers in the darker blue, mothers in the gold color, I would say, or yellow, and then child is the one in the lighter blue or greenish over here. Okay, so the method itself is still hist. Okay, we're still doing histogram because they're all numerical variables. Okay, and like I said, if all of them are numerical, in our case, father, mother, and child, all of the columns numerical, if you don't specify which column you're creating the histogram, the method itself going to automatically do all of the histogram for you and then overlay them over one over the other and then do the color coding for you as well. Okay, so before going forward of doing prediction, I guess maybe one thing we could think about is looking at this histogram. Okay, I guess one thing interesting is that, well, I guess not surprising, is that father's height overall is always taller than the mother's. Okay, that's how the 2 taller histograms are showing us. Okay, the child is sort of like an average of the 2. Okay, like of course it depends on the children's gender as well, I'm sure, but overall right now we're not collecting that information. We're only just showing the child's height compared to the mothers and the fathers. So I think that's pretty much what we can tell from this graph. Okay, so now moving forward to prediction, one thing we could keep in mind or even start to brainstorm is that, well, if I don't have the child's height, or like maybe like the parent or like the couple is thinking about having a new kid without having a new kid, for example, and then maybe one thing people want to do is, oh, okay, given the father's height, given the mother's height, am I able to do a good prediction of the child's height? Okay, so given what we have right now, it seems to be something like the average of the 2 to some degree. Okay, like, or some kind of average of the 2. So that's what I mean by like the prediction that Galton was doing like 100, a little bit more than 100 years ago by now, is nothing fancy. Okay, could be pretty intuitive to some people as well. It's like thinking about how we can make prediction of a child's height given the fathers and the mothers through some kind of averaging. Okay, and that's what we're going to do. And then of course, to make sure that we can do it in Python. All right, so let's get started. Okay, so the height, that's the data set, just to remind you. Okay, it's close to 1,000 records back there. So one thing we could do is, first of all, just to get a sense of what it looks like of the child's height. Okay, that's the one that we're trying to visualize. Okay, so the scatter, if you remember, okay, scatter is trying to give us a dot plot or a scatter plot, okay, about one numerical variable. And what's being done here is we gave Python, we gave the dot scatter method the column name child. Okay, so what's being plotted, okay, is the child's height. Okay, but one thing you might notice that because the data contains also the mother's height and the father's height. Okay, so actually more than that, what they're plotting, if you read it more carefully, is that on the x-axis, right, is the child's height. Okay, that's being labeled over there. Okay, on the y-axis, apparently they didn't give us the like the label itself, But what they do give us is color coding of the father and the mother. Okay, so we can understand that the parent's height is being plotted against the child's height. Okay, but then they're doing a color coding over here. The father's overall, as we can tell, if you remember from the overlaid histogram, the father's height is overall taller, and then the mother height is overall shorter. Okay? So this is just to get started. We're thinking about the child's height, okay, and then we're thinking about how father's height and the mother's height could help us to maybe make prediction about the child's height. Okay, so one thing, let's just do something simple to get started, okay? So we do know for each child, okay, we do know for each child, we have the father's height and the mother's height, okay? Maybe like a really crude prediction here is that, well, how about we just take the average, okay, of the mother's height and the father's height, and then produce that as maybe a possible height for a kid, okay? So the way to do it, okay, I'm gonna slow down over here. If you look at my box down here, is that we are adding a new column, okay, if you read it, okay, because we're using the dot with column method, okay? And remember, when we do that, we have two inputs, right? The first one is the name that you want to label this new column. The other one is whatever the array that you're doing, okay? For us, like I said, I was proposing, how about we're taking the simple average of the father's height and the mother's height, okay? And then add it back to the data table, and then trying to see if that can be something useful for us to predict as the child's height, okay? So because of that, the way I'm doing it is I'm gonna do the with column method, okay? I'm gonna name this new column called parent average, okay? And then the array that I'm doing over here is exactly what the name says. I'm doing the average of the mother's height and the father's height, okay? To do that, just to remind you one more time, because we're trying to create array, okay? And then we're trying to do arithmetic about arrays. So we're using the dot column method. Okay, we're using the dot column method, using the column name in quote. So we're able to get the array of all of the mother's height, and then the array of all of the father's height. I'm adding this two up and then divide it by 2. Okay, and because they are two arrays with the same length, right? So we're able to do arithmetic about them. Okay, so that's what we mean by here. We have all of the records mother's height, okay, in an array. Okay, we add it to all of the records father's height, okay, in another array. So do arithmetic about this. So we add them up and divide it by 2. Okay, it's going to give us an array of the parent average, just how we defined it earlier. All right, so maybe this all sounds straightforward enough for you, and that will be great. Okay, so if you look at the new table, okay, that we are returning over here, okay, the first 3 columns, they don't change. Okay, they're still the same as before, the father, the mother, the child. And now we're adding is what we call the parent average, okay? And you notice that, well, for the first 4, for example, well, the father's heights are the same, mother's heights are the same, and then, well, the parent average will be the same, okay? That's actually a quick way just to check that your work is right, okay? And then similarly for the next 4, same parents, same father's height and the mother's height, so then the parent average is always 71 for that 4 records, okay? And then of course the child record is from the original data, so it is what it is, okay? Make sense? Sense? Yeah, like I said, this could be like a very crude prediction. You might want to use it. You might think, well, might not be accurate and things like that. But at least one way now we start to see that when you want to do prediction, if you want to do it on the table, there are ways you can do it. Okay, and then especially using the table method like with column, and then of course the dot column method, we're able to get array of those numerical columns, and then we're able to do arithmetic about that. Okay, so I think to me, I think that's actually maybe more than about how accurate the prediction could be. This is a more important lesson about what we can do on Python tables. Okay. Alrighty, so let's see how that prediction or how that is helpful. Okay. So now I'm doing a scatter plot here, okay? We're doing the parent average, okay, on the x-axis, okay? The child is on the y-axis, okay? So what this is saying, if you think about like using the parent average to do a prediction, and do you think it's pretty high accuracy or like maybe not so good based on what I'm showing over here, this scatter plot? Okay, feel free to, yeah, I can pause over here for a little bit and then take a moment. I will still keep sharing my screen, and I will pause the recording. Yeah, so there are two numerical variables. So as soon as we plot it together, people, not surprisingly, will start to think about the correlation, or how strong the correlation is, how related those two, right? And then I think all of this are on the point, because when we're thinking about how good the prediction is, if like say parent average is not really correlated or highly correlated with child height, then it's probably telling us it might not be a good thing, or like it might not be a good predictor to be used. Okay, so that's, I think, why people are talking about the correlation, stuff like that. And I would just also mention that, like, say, another way we can think about this will be that, well, maybe for some of the records, let's just say for like, say, this one, for example, just say like this particular dot started like here in the middle. Okay, like for that dot, what that says is that the parent average is 66, right? And the child height is indeed 66. Okay, so when we're thinking about like accuracy to some degree, if that makes sense to you, is that we do wanted to see how close, right, the parent average is to the child height for every data point. Okay, and for that to happen, that 66, that was the one that I guess I was able to, eyeball and then sort of pinpoint over there. But then of course, there are all kinds of records like far away from that, right? For example, like this one, okay? This is the case where the parent height, I think, is probably like 73-ish or something, right? Whereas the child height is only 69. Okay? So these are good things to think about. Like I said, like thinking about correlation, how one is related to the other one. And then that might be telling us, okay, maybe directly use the parent average might not be the best, okay? But still, some of them are pretty good, okay? Some other records might be a little bit, having a little bit more noise over here. So let's think about what we can do over there, okay? So one step further of the parent average for prediction is how about like instead of like directly use the parent average for every record, okay, for us to do as a prediction, how about we pick a particular like small window? Let's just say like picking a small window of the parent average height, okay? So instead of using every dot for every dot, I'm thinking about like maybe I can use a really small window and then collect all of the data points in that window and then take their average. Okay, so it might sound a little bit complicated at this point, but let me show you what I mean. Okay, so for example, if I only want to focus on a small window of like 1 inch, okay, so for example, like if I focus on 68, okay, as the parent average, okay, and then I go below like 0.5, okay, I go above 0.5, so it's between the 67.5 and the 68.5. I'm trying to collect all of the records falling into this range, okay? I'm gonna use the average of all of those dots as my actual predicted value, okay? So whenever we're taking average, one way to think about it is that we're getting rid of some noise going on, okay? We can see that like between the parent average of between 67.5 and 68.5, like the parent average or like the child's height can still be like all over the place, okay? So what we're saying is that how about we're using the child's height over here, okay? And then we're using the average of all of the child's height, okay? Within this range for everybody in that range. So we're able to get a prediction over here. Yeah, so Samantha, please go ahead.
Hi, I was just wondering, so each line represents one of the red lines, so you have to code them individually. You can't just put a range. And also, what's LW equals 2 mean?
Oh, okay, yeah, no, great point. Okay, so Samantha raised two great questions. I guess I will answer the second one first. So that LW, I think it's line width. Okay, this is a plotting method. Like I'm adding this two vertical red lines over here and making sure that like they're thick enough so I'm able to read it. So LW stands for line width. Okay, you can, well, maybe I can do, I don't know, 5 over here. So we just might be harder to read, but you will see what I mean. Okay, they're just gonna get thicker. Okay, so that's what that is. Let me bring it back to 2. Okay. And the second or the first question Samantha asked, which we will see soon, is that, well, yes, looks like if we have to do this for every 1 inch interval, it seems a lot to do, right? Like to do this, like say we get the interval, we get the average, and then do that. So you will see that later on, we're going to streamline this, okay, using a function. Okay, that's what I mean that, okay, we're really trying to use function to do all of the prediction for us. So it's going to come up soonish. Okay, but yes, indeed, in the end, I think it's a good way to streamline it. One way, like you said, like what Samantha said, was saying that maybe we can do a make array. Yeah, so that will be one way to do it. Or we can actually do it as a function. So we're calling for any particular point going on. Okay, so more on that in a second. Okay, so let me show you.
One more question.
Oh yeah, go ahead.
And you can name it the same, because like you can name something underscore, and also you can name it twice, or because like it's not reassigned.
I didn't hear the last part. You're saying like, what do you mean by twice?
Like for the first one, it's like, first of all, you're allowed to name something underscore, and second of all, you have underscore equals the plot for the top line, but then you also have it for the second line, and it's not redefining it or reassigning.
Oh, I see. You're talking about this one. This one, right?
Yes.
Oh, okay. Yeah. Okay. So, right. So these are really, these are sort of, yeah. So the main plotting mechanism is still the scatter plot. Okay. So that's the main structure. Okay. And what we're doing here is that I think we're adding lines. Okay. So that's why we're using the underscore. It's not really, yeah, you can think of it as assignment. Yeah. And then it's going to show up as 2 lines over there. And for us, what we're doing is that, well, you can see that when we're adding lines, we want to make sure that we first input the x-axis, right? And we're actually just fixing it at 67.5 for the first line, okay? And then for the y-axis, we're doing it, I guess, just to cover the range of the data. So we're doing it from 50 to 85. We define it to be color red, and then we put the line width to be 2, okay? And similarly, we do that for the other line that we're doing, the second line, okay, on the right, okay? So this, again, this is adding on top of the scatter plot, that's the basic. We're adding extra lines going on over here, okay? And then, of course, we're doing 2 vertical ones. That's why we fix the x-axis, like even though they're interval, but it's going from its 1 to itself, okay? That's how we're able to fix the vertical lines. If you want to do like horizontal lines, you're gonna fix the y-axis in the same way. Okay, make sense?
Yes.
All right, great questions. Okay, so all right, so if now we were thinking about, like I said, between those 2 lines, okay, I'm collecting all of the height average, okay? I'm only gonna try to figure out like how to get all of those points. So in order to do that, now we know is that, well, I know I'm collecting the height, okay? And in particular, I'm collecting the height of the parent average, okay? So the way that we're doing it, so height is the name of the data table, okay? We do the where method. We put in quote of parent average, so working with that column. And then we're collecting all of the dots between 67.5 and 68.5. Okay, so as soon as we do that, let's see what we have. So we call it close to 68 just as a object so we can observe it a little bit more, okay? So what this happens is that we're doing like a subset, right? We're collecting all of the parent average between 65 and 67.5 and 68.5. And then we're putting everything into this new object called close to 68, okay? And we still have the father's height, mother's height, child's height, and the parent average. Okay, and then of course the parent average going to be indeed in that particular range that we have specified. Okay, all right, so for that prediction to work, okay, let's just take, okay, like I said, now we have this new data table, okay, only the ones close to 68 for the parent height, okay, and we're going to use all of the child's height and then take the mean of them. Okay, so that's why we are having this column out the dot column method, okay, because we're trying to get an array. Okay, we're using the child's height over here and then take the mean. So that's what I mean, like say, instead of using all of the dots, like just one at a time or one for itself, how about we're collecting all of them in a particular range, okay, of the parent average, and then trying to utilize them in a particular way that we are able to get rid of a lot of the noise going on. Okay, so one way to do that is take the mean. So we're taking the mean. Okay, so let me do that in a function. Okay, and what we're doing here is that predict children's height. Okay, and then the input is going to be what we call PA, just like parent's height. Okay, and we're pretty much like this function is wrapping up what we talked about the previous steps, like combine them. The first one is we have this close point object, which is a data table. Okay, we're doing height.where, the parent average, and then R between a particular range. Okay, and then you can see that this particular range is going below 0.5, going above 0.5. So whatever the input is, we are doing R between negative point, like minus 0.5 to plus 0.5 of the input value that we're doing. Okay, and then the second part is that we're returning the mean of the child's height of all of the records that we just collected, what we deem as close. Okay, so you can see that we always have the definition of the function, okay, and then we always need to have a return over here. Okay, for us, the return is actually just a scalar. Okay, and that scalar will be the predicted value that we're going to use. Okay, so let me try to demonstrate that for you. Okay, so we did that already. Like if it's 68, we know that the mean is 67.62. Okay, and then now we're running through the new function that we wrote, and we indeed get the same value. Okay, so that's just verification of our function is written at least in the way that we're hoping it's gonna function. Okay, and then for 62, then the predicted value is only 63. Okay, so let me run this for all of the data points that we have. It's gonna take a little bit time to run it. Okay, and then after that, we're able to see the prediction. Okay. So this does look slightly better, right? Like we have the parent average still being plotted on the x-axis, okay? The actual child height is all over the place, okay? But because we're using the mean of each particular parent average range as the prediction, we're able to get rid of a lot more of the noise over here, okay? And then the predicted value is being shown in yellow or gold, okay? Whereas the actual child value is being plotted here for you over the place. Okay, makes sense? So this is a crude prediction, okay? Like I said, back then, like nothing fancy really going on. And, but still, like I'm sure now there are more methods for a better prediction. For us, at least for this kind of crude prediction, we're able to use Python to realize it. Okay, we break it down into different steps, as you can see, okay? And then in the end, we try to synthesize everything through a function. Okay, so I will also recommend if you have other ways of thinking about making predictions, you can come up with maybe instead of like say, just for example, maybe instead of a 1 inch interval, I want it to be even more precise. Let's just say I want to do like a 0.5 interval, okay? So then one thing you could do is that to shrink this a little bit more by doing minus 0.25 and plus 0.25, and then use even a finer range of doing the prediction. Okay, maybe you want it even cruder, whichever, or even maybe not even using the average in the way that we're doing it. You might want to do something else, for example. So all of those, if you have a prediction mechanism you can think of, then try to break it down step by step, and then maybe finally also put it into a function so we're able to do that prediction for all kinds of records, not just for a particular one. Okay, make sense? Make sense? All right, okay, that's good. And that's pretty much what we have for topic 7 functions, okay? And then that's involving, of course, a lot of things about the table, okay? Depends on the methods that you're able to apply to a table. And then of course, depending on the goal that you're working with. So we want you to think a little bit more creatively, okay? And then for us, we show you one way to do the prediction, okay? And then once we know how we want to do the prediction, I guess the remaining task becomes how we can make Python code in a way that is doing the thing that we want, okay? But then, like I said, you can always come up with other ways that you want to do the prediction itself. And then that will involve different ways of writing the code, okay? And then sometimes you do have to break it into multiple steps, and totally feel free to do that. And Jupyter Notebook, as we know now, you can create new cells and then test it out. You can delete it afterwards, things like that. So those are good things to use, okay? But in the end, since we want to do this at a mass scale, in a sense that we're doing prediction for every record, or in that case, so it's probably always a good idea in the end to write it as a function, okay? Because you're able to apply it at a wider range, okay? So that's, I think, some important lessons from this topic.